If you have taken the mechanical design class, you heard us talk the first day of the term about things you can do to be a designer. And one of the things we suggested was start keeping a file or a notebook or something, start keeping a record of examples, because you never know when you might be faced with a task. And having examples is really gives you a leap ahead. So one of the things I collect examples of is guards, because when somebody says, hey, here's this machine, why don't you design a guard? You don't want to just say, oh my gosh, I have no idea how to do that. You want to go, just a minute, let me go do a little research and I'll get right on that. So let's look at some ways that you could do guards. One way you could do a guard, you can make your own guards in your company's shop. And you can make them out of plain old sheet metal. Here are some examples. In the two upper left pictures, you'll notice here are some guards that are quite simple. They're just flat pieces of sheet metal. This one has a little bit of a bend in it. This one has some slots for adjustability. Those are fast and therefore inexpensive. This one here in the upper right is carefully designed to fit around two shivs with a V-belt drive. Now, sometimes you need to do that for whatever reason, but be aware that it does take up extra time in the shop to be fabricating all that stuff. Here are some other examples. In the top picture, this is from Peterson, here's an example that I referred to earlier when we were talking about nip points. And I mentioned that you might not need to have a guard around the entire rotating thing if it's the bottom of the rotating thing and there's no nip point. So this is probably a head pulley on a conveyor maybe, and the belt will be going this way, so it cannot suck the operator in, so you don't need a guard to go all the way down. Now notice on some of these examples how a guard can serve more than one purpose. If you go out and talk to the people in the shop, and I really hope you do, because they are the experts in making this stuff and sometimes in using this stuff. So if you go out and talk to the people in the shop, let's say you're designing this white belt guard here, they might tell you, you know, if you put some Gratex steps, welded some steps on here and put up a handrail, I could use this thing to climb over the equipment. So now it's not just a guard, it's a thing to climb on. And you will say, that's a very good idea. I will do as you suggest. Notice also on the underside of this white thing, you might go out and talk to the users out in the field, and they might say, you know what, I have a guard like this and it just fills up with wood chips and dirt, and then the thing bogs down and stalls out, and then I have to take the guard off and clean it. If you could put some kind of openings in the bottom of the guard so the stuff can fall out, then I won't have that problem. So you can put, here they've cut slots in the bottom of the guard to let the dirt and sawdust fall through. In the well, in really all of these examples, you'll notice there are some openings here and there. Those are very useful for the operator to look through and see, is anything plugged up? Is everything running right? Do I notice any problems without having to take the guard off? Here are some more, two more views of those same guards. And then here's this one. I don't know what this designer was thinking with all these punched holes. I guess they wanted to be able to see in a lot of places in this belt drive. A variation on sheet metal is a thing called punch plate, which is where you take sheet metal and you punch holes in it. And if your shop has a CNC punch or a CNC plasma cutter or a CNC laser, CNC stands for computer numerical control, it is real fast to cut these holes, and you in your CAD drawing will just design the holes or slots however you think would work out well, and then they punch them real fast in this sheet metal. And now we have a nice simple guard. It can be formed in a press brake simply. It's got holes in it so the operator can see what's happening in there. Here are some more examples of sheet metal with holes punched in it. Here's an example. This was at Pacific Metal over at 2nd and Chambers. So they had a customer job. I forget what this was for. Some kind of computer stuff, I think. And so here is the flat sheet metal with the holes punched in it. And then here is the flat sheet metal formed up. So notice that the nice thing about punch plate is it's just like plate. You can form it, but it's got holes in it. Here's a Peterson Pacific thing. Easy to form, easy to bolt together or weld together. Then some designers like to use expanded metal. You can use either that raised expanded metal, one brand is Gratex, or the flattened expanded metal. But in any event, it's got holes all over. It's just solid holes. So you can easily see through wherever you want to see through. Here's some more examples. More examples. This is quite common. You see this a lot. This used to be Weyerhaeuser in Springfield. Now it's International Paper. A variation on that, I think, stuff with holes all over, is a thing called wire cloth. And wire cloth is just like great big screen. It's pieces of wire woven together. That's why they call it wire cloth. And you'll notice that it is also very easy to see through, and like punch plate and expandex, it's strong. In my opinion, I would think that it would be annoying to weld the wire cloth inside the frame because you got these little tiny pieces of wire. I talked to some welders at Peterson Pacific and they said, "No, we don't care, it's fine. We just weld like every third wire or so and no problem." And notice how easy it is to see through. This one here in the upper left is a guard over a belt conveyor. This is a big old long belt conveyor, probably carrying pit and quarry stuff, and you can see how easy it is to see through. In this last slide, this is from Peterson again, and I wanted to show you how you can actually form wire cloth in a press brake and then weld it into a frame and be able to see and have some cooling functions and all kinds of great stuff. So you can just do all kinds of things. The point I want to stress to you is start collecting some examples so that if you are faced with designing a guard, you will have some ideas for starting points. And then maybe you can go out in the shop and discuss this with your experts out on the shop floor.